Today, I'm going to teach you how to use Matlab to write custom SVG code for input into a laser cutter to make any shape you want. The first part we want to get right is the input function. The input function asks the user for a value and assigns it to a variable, and it's doing that right here. In addition, after the user inputs a variable, it gets parsed into this while loop to make sure that the value they put is a legit value for our width. So if I hit run and I choose 200 for my width, it's going to be too big. If I choose negative 100, it's going to be too negative, and then I'm going to choose 100, and now width is set to 100. In addition, you can go over here to the MathWorks page to find out what the input variable does. The next thing we have to do is determine how an SVG works. This top line here defines the bounds of the actual file itself. The next line defines the color, the radius, and the position of the rectangle, as well as its height and length. This is important because we're going to be importing this format of an SVG into our Matlab fairly manually, and then importing this into a text file that is saved as an SVG, and that will give us an SVG that we can open on our internet browser. The next important tool is the fopen function. The fopen function creates a new file and it opens it up. Here we have our file name rectangle.svg. If you label it .svg, it will turn into an SVG, and we have this W here, which means write, and which means that it is now expecting us to write code into this new file called rectangle.svg. So here we have another variable called format SVG. And what this is basically doing is it's taking this text, which is written in SVG format, and putting it into this rectangle.svg file. Within this SVG format here, you can see a couple of % signs followed by a D, or in some cases an S. What this means is that it wants to replace this D with a number. So D stands for digit in this case. We're replacing these D values down here with this variable, which I just happened to name Bob. And Bob is an array with different values that we're going to input into our lines here to create 4 lines that form a rectangle. So if I use the fprintf function with the file ID, which is the open SVG, and the format SVG, which is the content, and then the Bob variable, it takes all of these and replaces these digits here. You can learn more about fprintf and fopen on the MathWorks help page. But for now, we're going to run the code with inputs to our width and height. And then we're going to check our folder that has our MATLAB code in it for our SVG file, which is right here, the rectangle. You can see it was updated recently. And here we have our rectangle. Ignore the error. We're going to apply these same principles, except in this case, we're going to use the string concat tool instead of what we were using before. And we're going to add different shapes such as circles, an image of the Columbia logo, and different rectangles to cut out slots for our piece. So I'm going to run my code. I'm going to choose a length for my rectangle, a height. I'm going to put text on the top. I'm just going to say top. I'm going to put text on the front. Just going to say front. And then it creates my file. If I go over to my folder and I find dynamicoutside.svg and I click on it, you can see that it creates a very long SVG file with all of the different components that we have. It's just a straight line, but it works for our purposes. And if we go into our file and we hit dynamic outside, we get our SVG that pops out here. We have circles here for screws to keep our box together. We have our top box input text. We have our front text, which I misspelled. We have digital manufacturing, which was put in before, and we have the Columbia Crown logo. Each of these little rectangle with rectangle arrangements are meant for our screws and our nuts, and they were created offsetting a little bit from the center of our rectangle, because rectangles go from left to right, and moving the vertical rectangle up to the left a little bit so that we could put our screw in. If you want to make this more complicated, you can ask the user for how many sides they want their container to have. And after they choose a side, it will ask them for their length and their height. And after that, it will parse into a function. This custom function is another MATLAB file that is within the same directory as our test.matlab file, which is where this code resides. And it basically will do the same thing. So I'm going to hit run, and it's going to ask me how many sides would you like your top and bottom face to have. I'm going to do 4. This can say what's the width of your rectangle, because 4 sides is a rectangle. I'm gonna do 100, do 100 again for the height. Then it's gonna ask me what would you like to engrave on the top, and I'm just gonna put test, test, misspelled the second test. And after that, it should have created its SVG file. And if I go over to test rectangle and open it, or I can open it over here, you'll see test test pops out from our function. Next, what I'm doing here is I'm importing my SVG file into the laser cutting software. And so what I want to do is I want to make sure that I have stuff that I want cut, and stuff that I want rastered, which means like put into the acrylic but not cut all the way through on the raster setting. So the boxes, the screw holes, the screw and nut assembly, all I want to be cut, and all of the words and the Columbia Engineering logo I want to be rastered. So in this video, I'm just importing it and doing that. Next, what I do is I put my piece of acrylic onto the bed, and I make sure that it's in the top right corner. Then I go over to the controls on the right and I do a process called auto leveling. Auto leveling ensures that the laser is an adequate distance away from the acrylic and makes sure that I don't have any gap there that would make my piece not get cut all the way through. In addition, I'm going to do a step called framing, which is where the laser head simulates a path of where my cut is going to be. So it's going to take a big rectangle to make sure that my laser will be within the bounds of my acrylic and I don't cut the bed or the grate. Then I'm going to close the laser and I'm going to run my cut. You can see the laser slowly tracing out the square there, and it's going to do that for a few more seconds. Here is another Manger, and brace for the laser sound. Finally here we open the laser cutter and we can see that it looks like it went all the way through. I'm going to just check with my finger real quick to make sure it wobbles a little bit, and that tells me that it's gone all the way through. Here you can see me putting together the rectangle. It's a little bit difficult because the circles are tangent to the edge of the rectangle, so they tend to not stay in place. Also, the nut can fall through the hole for it pretty easily, so you have to be careful of that. But eventually, after some trial and error, I get it together and it has a lid now. Thank you for watching. Like, comment, subscribe, share with your friends, and let me know if you have any questions. And this project has been for Digital Manufacturing Spring 2024.